We will be once again referring to this particular flowchart in order to perform certain tests. Until now we have discussed about one sample sign test, one sample t-test, one sample z-test, two sample t-test with equal variances. And unequal variances is all about removing the check mark on Minitab dialog box. Okay, so we are more or less done with this part. Now let us proceed further and understand a few more things. Here is a case study. Let us read this and try to understand. Effect of fuel additive on vehicles is being studied. Out of the total of 20 vehicles, 10 vehicles are chosen randomly and mileage is recorded. In the rest of the 10 vehicles, additive to be tested is added with the fuel and their mileage is recorded. So out of these 20 vehicles, for 10 vehicles, you did not add additive, and for another 10 vehicles, you have added additive. We need to determine on whether the mileage increases by adding the fuel additive. So here we are comparing two populations with each other. We are comparing the mileages of the two vehicles. So Y output variable is the mileage and X are two categories, that is one with additive and another is without additive. So we have with additive and without additive. These are two discrete events. And mileage would obviously be continuous, right? So if you have the output variable which is continuous and if you have the input variable which is discrete in two categories, then we need to traverse this path. We are comparing two populations with each other, mileage with additive and mileage without additive. What is the first step that we need to perform here? We need to perform normality test. So let us write down. The first test is normality test. And for the normality test, null hypothesis says data are normal. And alternate hypothesis says data are not normal. If data are not normal, we need to transform the data and ensure that data becomes normal. If despite transformation, if the data does not become normal, we proceed with non-normal techniques. And here we are going to discuss about Mann-Whitney, which is one of those. All right. So let me open the dataset using Minitab and perform a normality test. So there we go. Now this one, I believe this one, yeah. So we have two vehicles. You're testing the mileage of these two vehicles with and without additives, right? First thing is, let's check for normality. So I'll go to stat, basic statistics, normality test. We'll first select without additive and test this. By looking at the graph, I get a sense that data follows normal distribution because the p-value is 0.73. Okay. So I'll go back here and I'll say that p-value is 0.713, which is greater than 5%, which implies that p high null fly, meaning we fail to reject null hypothesis. So data are normal. But data are normal for what? This is for without additives. Now we also have with additives. Let's see what happens. So I go back to the worksheet. Here is the data set. I'll click on the last dialog box and select with additive. Interesting. The graph somehow shows that data are not normal. You have all these variables which are kind of dropping on this particular line. And also look at the p-value. It is 0.026. So p-value is 0.026. If p-value is less than 0.05, what does that imply? P low, null, go. So we are rejecting null hypothesis, which says that data are not normal. This is with additive. If data are not normal, we need to transform the data. Okay, we need to transform the data and check whether data follows normal distribution or not. However, assume that we have done that transformation and despite that data does not follow normal distribution. If that is the case, then look at this, look at the flow chart. If data are not normal, we need to proceed with Mann-Whitney test. We need to proceed with Mann-Whitney test. That is what is given. Step 1 is check for normality. If the data are not normal, proceed with Mann-Whitney test for medians. So let us also write this. This is the first one. Second step is we need to perform Mann-Whitney test. Here also we need to write null and alternate hypothesis. Okay. Now, this is all about test for medians. So, medians are the same. And here, alternate hypothesis would be medians are not the same. Because if the mileage of the vehicle with and without additive is the same, then you need not take any action. That means the additive is not helping you. However, if there is a difference, that means the additive which is getting added to your vehicle fuel is actually helping, increase or decrease the mileage basically. So we can do, a couple of tests here. The first thing is, let us perform this kind of a test and let's see what happens. So I'll go to the worksheet here. We need to go to stat, non-parametric, and Mann-Whitney. Okay, so we have one sample which is without additive. We have another sample which is with additive. Confidence level is 95%. And what is alternate hypothesis? Medians are not the same, not equal. Okay, so let me click on OK. And here you see this 0.4497, right? Test of medians equal to versus not equal to is significant as this. And this p-value is greater than 0.05. So let me write it down, 0.4497. 0.4497, and this value is obviously greater than 0.05. What does it imply? P high, null fly. All right. That means we fail to reject this. That means medians are the same. That in turn means that there is no reason to believe that mileage of the vehicles with additive is actually different. There's absolutely no reason to believe that. Right? That is what you go back and say, hey, we should not be marketing this additive because introducing the additive to the fuel is not actually increasing the mileage significantly.